Hi everyone. For this question, given you a function of log, the first one show that the function is one-to-one function. So we will start with fx1 equals to fx2. So substitute x1 into the function ln x1 minus 1. Substitute x2 into the function ln 2x2 minus 1. So when you have one log and another log, in the both side here, single log here, you can unlog. So when you unlock, we are going to find out what is your x1. So make sure your step is clear one by one how you get your x1. So move your 1, you get 2x1 equals to 2x2, and we move the 2, x1 finally equals to x2. We have one answer only. So when we have this one answer, which means that you need to write out the conclusion. This function is one-to-one function. And then we continue to the part B, find the inverse function of f. So to find inverse function, we use composite method, which is f inverse equals to x. We're going to substitute f inverse into the x for the function f. So therefore, we can get this one ln 2 f inverse minus 1 equals to x. So we need to clear off the operation at the left hand side to find out your f inverse. So unlock first. When you unlock, the base e will move to the opposite and this x will become its power. And then we simplify the one, it will be ex plus 1. Then finally your f inverse will be ex plus 1 over 2. Then we continue for the question C. Find the domain and range for the function and the inverse function. So first we find for the domain for the function first. Domain for the function DSLR. So log we need to calculate. So how to calculate is inside the log here, it's supposed to be greater than 0, not equal to 0, because we have non-zero, it is invalid. So only 2x minus 1 greater than 0. So x will be greater than 1 over 2. So which means that this is 1 over 2 until infinity. 1 over 2 is not included. And this not included value 1 over 2, x1 over 2 is your vertical asymptote. It's a asymptote for your log graph. And when I come to the range of the function, range, we are referring Kastler, so we don't have any log function mentioned here, means in the range it is not a special case, it's just negative infinity to infinity. And when we want to refer to the domain of f inverse, we will refer domain f inverse, which is range of the function. And range of the f inverse, it will be domain of the function. And then for the last here, we're going to draw out the graph. So graph of log. Graph of log is the shape of Tiangnan-pu with the maybe at the right or maybe at the left, or maybe your log will be inverse. So we look at your domain first. 1 over 2 to infinity. It will be showing that to infinity means going to the right. So going to the right, so here will be its basic shape. The shape here is like this. So whether you're going to terbalik or not, inverse or not, so we see the log function here is positive, so we no need to terbalik. Therefore, we can start drawing here. And this graph, we need to inverse. We need to draw the f inverse. Once we need to draw the f inverse, meaning that we need your axis of reflection. Y equals to x, which is pass-through origin. And Look back our domain. Our vertical asymptote is happen at 1 over 2. Here is our vertical asymptote for your log. And when my log here is going this shape, so the things we need to concern here, whether our log is going beyond, above axis of reflection or below. So our log may be like this, or maybe it's going up, or it just touch, or maybe it's going more higher than the reflection axis. So when we just concern about this, we can test with your calculator. So set your calculator mode into the table. We just need to find out their coordinate so that we can be sure that the point is going above or below the reflection axis. So our function here is log in the bracket here 2 alpha x minus 1 and equals to start with the asymptote 1 over 2. Ending, just we give a range here. Just let's say I want to ending with 10. And step means how many scale I want to put here. Maybe I can put 0.1. So when you come out with this means my scale is too small or our value is too big. It cannot calculate too much of the point. We start again with 0.5, 1 over 2. Maybe ending I put 5. And then my step I put 0.1 so I can see the graph. So still not continue. So maybe I change the step to 0.2, bigger a bit. So we can see at 0.5 error means this is asymptote. Of course, it won't have any graph here. As you can see, when you go it more, as you going to the right, you can see 0.7, 0.9, then 1, 1.3, then 1.5. As you can see, your coordinate and y coordinate here, your y coordinate always smaller than x coordinate. When you have coordinate 2 point something, your y coordinate also smaller. What's mean by that? If your y coordinate keep on smaller than your x coordinate, means it will not overshoot, it will not go above your axis of reflection. Because axis of reflection is y equals to x. If your x is 4.7, your axis of reflection also 4.7, but your graph only 2.1, means your graph is always lower than your axis of reflection. So therefore, our log graph here, so here is the asymptote, and then we just shoot up. Never go through above it or never touch it because we can't see any value which is same or more than that. If you're having the same, let's say 0.7, 0.7 means it is touching the reflection axis. Now, if you have the value of coordinate always smaller than that, so your graph will not go above than your axis of reflection. So when you draw your long graph, there are tiang lampu, make sure your asymptote you go near to it and this is shooting, is not coming down or is not going constant like that. So it should just go up. The graph still looking like it is going up. Alright, so don't curve down. Then our next step is going to label. This is our original function, fx equals to ln 2x minus 1. And we have a x-intercept here. So x-intercept here is let y equals to 0. So when you let y equals to 0, we calculate ln 2x minus 1 equals to 0. You can use calculator also. We key in this. Clear this calculator mode first. We take ln and then 2 alpha x minus 1 and then we get it equal, not this, equal. So take the equal sign from the red color one, means you need to press alpha equal to 0. Then we ask for solve. Shift, solve. Solve for x, finding x, yes, equal. Until you enter equal, until you get the value, you can see calculator help us to solve this. X is equals to 1 here. Finish up your graph of fx. Now we're going to do reflection, so that we are going to have our axis, so that we can have our inverse function. Alright, so first step, inverse reflect your vertical asymptote. So the vertical asymptote is touching here. Therefore, your horizontal asymptote also need to come up with here. Your image should be generated here. Not up, not down. So look at your point here carefully. When you touch here at your axis of reflection, so here is the point that you were having your horizontal asymptote. Y equals to 1 over 2, label straight away. This is x. When you reflect, become y. Y equals to 1 over 2. Then we will reflect the graph here. So we're going to reflect. So going to having a reflection, symmetry graph. Try to get the image symmetrically. Alright, try to get your image symmetrical when you're doing reflection. So here is a 1. When you reflect here, we get 1. And then don't forget to label your F inverse. So this F inverse is EX plus 1 over 2.